Hello friends, this is Computer Networks class 6. In previous class we have learned 2D parity in Humming code. Here we learned further the Humming code. If we have a 3-bit of data message, for 3-bit of data message we need to be a 6-bit of Humming code, because in Humming code we have add 3 parity bit for 3-bit of data. These are the code words. If there is a 6-bit of code for 6-bit, there is a 64 code words are generated. Out of 64, there is only 8 code words are valid code words. These valid code words are block code and the linear code. We have learned what is the linear code. Here we can also explain. Here, if we take a 2 binary string and doing the job of these 2 strings, then the resulted string will be come from this block code or a part of this block code. It is not a cyclic code. We see that we rotate the string, then the outcomes, the resulted string will be not a part of block codes. Okay. Then Humming bit. What is Humming bit? Humming bit is a number of ones. If in any binary string the number of ones contained is called Humming bit. Here there is a 5 number of ones, so the Humming bit is 5. Now the Humming distance. If we have a 2 binary string of equal length, if we taking a bitwise XOR of these 2 strings, we get a result of another binary string of same length, and the Humming bit of that resulted string, the Humming bit of that resulted string is called Humming distance. Here there is a 5 number of ones, so the Humming distance of that result string is 5. Let us suppose we have a 4 code words. These are 4 code word. Code word means these are the valid strings which follow the Humming code. Here the minimum distance, their Humming minimum distance is 5. How to find the minimum distance? If we take a XOR of these 2 strings, we get a minimum 5 ones, taking with this, and this string with this. After doing all of this, there are C1, C2, C3. There is a 4, 5, 6. There are 6 types of combination we made from this, and after make combination of these 6, we get a minimum distance is 5. So the minimum Humming distance is 5. So the case number 1, no any error. If we transmit the string and the same string will be received by receiver, then there is a no error detection and code word is accepted. If there is 1-bit error, if we transmit a code and the receiver will receive a code with 1-bit error, which is a invalid code, which is not belong to our valid code words. These are the valid code words. So error detected, yes, the error detected by receiver end, so the connected code word. So what the receiver do? Receiver match the received code word with valid code words. If the receiver match this code word with valid code words, from which valid code words the received code word will have lowest Humming distance. Here the receiver will find out the lowest Humming distance with the received string and the valid code word list. Here if we find the Humming distance between received code and C1 code, we get the Humming distance 1, and here with C we get a Humming distance 4. So with C1 the Humming distance will be 1. So this is the lowest Humming distance. So receiver will replace C1 with received. After finding the lowest Humming distance, receiver will receiver will replace that valid code words with the received code word. So the corrected code word will be C1. Another second case, 2-bit error. When there is a 2-bit error, this is a transmitted code and the received code by the receiver. Here the 2-bit error. So error detected by the receiver. Now the receiver will find out the minimum humming distance with this string and with valid code words. There are 4 types of four valid code words. So the receiver will find out the lowest humming distance with these valid code words. Receiver pick one of the valid code words and taking out the XOR and the resulted outcomes and find out the lowest humming distance. If the receiver found the lowest distance binary string, then it replaces with that. So here error detected and corrected code word is this. This is a corrected code word, because with this there is a lowest humming distance. So again there's 3-bit error. When 3-bit error, there is a 3-bit error detected by receiver, yes, but if the receiver went to find out the minimum humming distance with this string and the valid code words, the receiver will found that there is a lowest humming distance with C2 string. With C2 string, there is a lowest humming distance of received string. The receiver will conclude that C2 is a valid code word, but actually the code transmitted by transmitter is different from the result of the receiver side's code. Means that after applying humming code, lowest humming code distance, the receiver will get the result and resulted with get this string, but it is not an actual string which is transmitted by the transmitter. So the wrong code word is accepted by receiver end. In case 5, if there is a 4-bit of error, then the error is detected by the receiver end, and if the receiver check the humming distance with the received string and the valid code words, the receiver will found that the C2 code word is a code word have lowest humming distance with received code word, received binary string, received code word. So in receiver end, receiver will get C2 code word as a valid code word, but the actual transmitted code word is this, but receiver accepted wrong code word. So in 4-bit error, the receiver will not find out the correct transmitted code. Same thing happens in bit error. 5-bit error, the transmitters send a code word and the receiver received the 5-bit error code. 5-bit error string. So here the error is detected. No, there is no error detected because this is a valid code word. So error detected nahi, and the wrong binary string are accepted by the receiver end, because the actual string transmitted by the transmitter is which contain all zeros, but the accepted string which is also a valid string from code block, and receiver will accept it. So the receiver accept wrong valid code word. Okay, this is not a original one, but this is a valid, so receiver will accept it. So receiver will accept wrong data. It's in with fifth bit. So again with fifth bit of data, but different place. Here the transmitted code, here the received code. Received code, there is a 5 bit of error, but the places change. So error detected, yes, but error correction, if the receiver will find the lowest humming distance with valid code words, then receiver will get a valid code word with the humming lowest distance, but the receiver concluded string is not the same with the original one. So the conclusion out of these 6 is the result of these 7 cases comes here. Finally, the result is that if the humming distance is d, then the receiver will detect up to d-1 error. d-1 means that if there is a 5 bit of the humming distance of that string is 5 bit, but the receiver have detect only 4 bit of d-1, the 5 minus 1, there is a 4, which means that the receiver will detect only d-1, means the humming distance is 5, then the receiver will detect only 4 bit of error. Here we see that there is a 2 bit error, 3 bit detected, yes. In case of 4 bit, error detected, yes, but in case of 5 bit, error is not detected. Okay, then again an error, the receiver can detect only d-1 by 2 bit of errors only. d-1 by 2. Here there is a 5 bit of humming distance, so d is 5, d-1 upon 2, so d-1 means 4 by 2 is equal to 2, means that receiver will detect only 2 bit of error, Here 1 bit error is detected by receiver and corrected by receiver. Okay, if in case of 2 bit error, yes, the error is corrected by receiver, and but in 3 bit of error, receiver corrected code word is not same as original one. So here the error correction method will fail. So the error correction method is valid only in 2 cases, 1 bit error, 2 bit error, if the humming distance is 5. So that for detection of k bit error, if you want to detect k bit of error, there should be a minimum humming distance should be k plus 1. To detect k bit error, we should have k plus 1 number of humming distance. If we want to correct k bit of error, we need to be a 2k plus 1 humming distance, because we knew that in 5 humming distance, the receiver will correct only up to 2 bit of error. So after applying the formula, we get 2. Here again we see that cyclic code with 1 bit parity means that if we have a 3 bit of data, and by using a 1 bit parity of error detection, we append 1 extra bit, and we will generate a valid code word. In 4 bit, there is a 2 to the power 16. 2 to the power 4 means 16 there is a code word. Out of 16, there is a 8 valid code words, and these are in block codes, linear code, and cyclic in nature. In cyclic code, in CRC, if we use a CRC method for error detection, if we have 3 bit of code, we need to be a 6-bit of code word. We need to be append 3 extra bit for error detection, which is equal to be a generative polynomial function, which is equal to a degree of generated polynomial function. So these code words are also block codes, linear code and cyclic code. Now in case of Humming code, there is a linear code because this is not a cyclic code. In Humming code, if we have a 3-bit of data, we have to append 3 parity bits. So the code will become 6-bit. These code words are blocking nature, block code and linear code, but not in cyclic code. Thank you.